Hi guys. Today we are discussing ocean warming and ocean acidification in environmental science and nothing else. And I'm going to back up here to number 20 in our notes on this section on, what was this section on? Global climate change, just to make sure everybody got these last few notes. But we got a lot to talk about today. Don't forget we have a test next Thursday. Try to get through with notes by Tuesday so we can have a review day. And then at the end of class today, we'll try to spend the last 15 minutes or so working on your lab analysis from our carbon sequestration lab yesterday. And hopefully we can get that turned in, see how many trees it takes to offset our CO2 emissions that we have. So really quickly, going back to did we get through 21 in here?
No, we got to 20.
We got to 20?
Yeah.
Okay, well, it's a good thing we're going back. Number 20. And you guys can turn back to about 536 in the book, somewhere in there. So, 536 at the top talks about melting polar ice caps, and the ice level, as you can see here, have decreased significantly over the course of the past 20, 30 years there. Remember that whole area where we would call the North Pole is not actually land. All of that is the Arctic Ocean. And a lot of the year it's frozen, and a lot of the year a lot of it thaws out. And so, was it currently up to 39% smaller than during the summer than it was from 1979 to 2000. So that's a pretty dramatic decrease. And we talked about we would expect that to increase because of what?
Rising temperature.
Well, yeah, and the more ice that melts, the more water absorbs.
Yeah.
What do we call those?
Positive feedback loop.
Positive feedback loop is more ice melts and more water absorbs more energy, thank you, heat, and then it's going to melt more ice and keep moving in that direction. So, number 20, global climate change response time in the Arctic is due to positive feedback loops. We're going to kind of discuss this a little bit, involving the melting sea ice, where ice reflects a lot of light, a lot of the light coming in from the sun, and so as that ice, the earth warms up, the ice melts, water absorbs more heat, the more heat, it's gonna heat up the earth, which is gonna increase the rate of melting of the ice, which causes there to be more water, which absorbs more heat, which melts more ice, and it continues to move in that direction. So that's a positive feedback loop that is pushing some phenomenon in one direction. Remember, positive feedback has nothing to do with being positive or good. It has to do with it keeps it going in that direction. It's like it's adding. Whereas negative feedback, something's going in one direction and it moves it back in the other direction. And we're going to go through another example of that in a minute. But before we do that, let's see. Melting sea ice and thawing tundra. So I would just throw in permafrost in the tundra there. So in the tundra, there's lots of permafrost under the ground. And as that melts, what the organic matter that's there that was frozen starts to break down, and what is released? Methane. Okay, we talked about methane hydrate, where you basically have methane that's mixed in with the water there as the permafrost melts. And then, or AKA fire, ice. And then the other thing that's released as stuff breaks down is? CO2. Yes, diseases are bad too, but that's different than our greenhouse discussion, but also may be very bad. So we've got to worry about as the permafrost breaks down. So as the permafrost melts, more CO2 and methane is released, which is going to cause temperatures to go up, which is going to cause more permafrost to melt, which is going to cause more CO2 and methane to be released. Temperatures go up, and that's another example of that positive feedback loop that we see due to climate change. Okay. And subsequent release of greenhouse gases like methane and CO2. We watched a little bit of the video on the fire ice, right? The girl was lighting the
Yeah, it was like a. Yeah.
They put the stick in the ground and
And then it was like
yeah, they had like the metal poker, and they had the bubbles under the ice, and then they lit them on fire. We will get to that, probably hope we finish up next week. Because the second part of that video, they're going into like some tunnel that was built during World War II as protection from the Russians. And it's really cool because like this tunnel that they built, I mean, there's just like mastodon, I don't know if maybe it was steppe bison. There's like skulls hanging out of the wall and bones and stuff of just these Ice Age animals that were all over the place. And as they dug through there and dug that channel out, or dug the tunnel out underground in this frozen permafrost, all these ice age animals, it's like literally looking back in time. Yeah. Sophie?
I don't have a question.
You just got your hand up? Okay. Sophie doesn't have a question. How are things in the kitchen?
They're pretty good.
How's the remix to ignition?
I'm fresh out the kitchen.
Okay, so number 20. Well, hold on. Let me give you another example of negative feedback loops since we talked about positive feedback loops. And let me see. I think it's on page 35. Yes. So on page 35 at the top of the page. So remember, negative feedback loop, like a good example we talk about in bio is you get hotter, you're working outside, your temperature goes up, you start sweating, and that is to bring your temperature back down. So negative feedback loop, negative doesn't mean bad. Negative means something's going in one direction and it brings it back the other way, okay? So an example in environmental science is on 535 from your book. Because CO2 is required for photosynthesis, an increase in CO2 can stimulate plant growth. More plants will cause more CO2 to be removed from the atmosphere. And so basically what it's saying here is you increase the levels of CO2. The more that CO2 is available, the more plants will grow and take it in, and it will reduce the kind of increase that's taking place. So the increase in CO2 we see now is suspected to be slowed down by that increase of taking in of CO2 from plants because of the higher concentrations. Now, and I don't know if we talked about this the other day, so let's look on 530 real quick. When we talk about ocean warming and increase in temperatures, I don't know if I mentioned this. This book that we're using is about 10 years old. What's better than no book, right? So current levels on 530 of CO2 is at what? What number? Yeah, I think it's roughly about 390 there. Hold on, I'm on the wrong side of the page. There we go. So the levels in 2010 are right about 390. Now, I looked the other day at the latest observatory readings, and they were around 415. So we've had a pretty big increase. You know, historically, you can see here the ranges go from about 180 to about 280, kind of off and on. I want to say in roughly 100 years ago, in about 1920, we were at about 315-ish. So over the course of 100 years, basically we've went up 100 parts per million of CO2, which is almost a quarter increase or 25% increase in CO2 in a very short period of time, okay? Which seems like a lot, and it is a lot, but if you think about, you know, we've ramped up to almost 8 billion people at this point, and there's a lot of fossil fuels being burned and CO2 being put in the atmosphere. Okay, things we need to talk about and add in before we go on that I'm afraid you may see on the test that are not exactly specifically listed in here. Let's turn over to 541. So, Luke, we talked about the Montreal Protocol that dealt with the reduction or getting rid of the production of what? 1987, Montreal Protocol was signed. We're going to start producing CFCs. Good. And then in 1997, a bunch of countries got together and they said, hey, in Japan, Kyoto, Japan, and they said, hey, climate change is an issue and we need to stop production of our fossil fuels or reduce our CO2 production. We got to do something about this. And so this is 24 years ago. This has been a while. What was called the Kyoto Protocol was signed, Caleb. And the Kyoto Protocol said basically we're going to reduce our CO2 emissions by a certain amount. Now, you can read through there. It talks about how much reduction and blah, blah, blah. But basically, the U.S., China, and India, and I think Russia's also thrown in here, but we're not worried about them right now. No offense. Those three countries were like, and I think Brazil was another one maybe. But those are the three main ones I want to discuss. Said like, hey, we're not going to sign this or go along with the Kyoto Protocol. Why do you think the U.S. wouldn't sign that reducing measure for getting rid of or reducing CO2? Why do you think we didn't want to reduce fossil fuel usage? Yeah, I mean, there's not a good backup. And I would say the main reason is because China and India didn't want to sign it. And China and India didn't want to sign it because... Yeah, so China and India are becoming industrialized, especially if you think back to 1997 with China. China's getting closer and closer. And so they're like, hey, you guys have been using fossil fuels for 100 plus years. and you've had this cheap energy source, and you've developed, and you've got richer, and now we want the opportunity to do the same thing. And the U.S. is like, well, hey, we understand that this is an issue, these things are bad, but if we stop using fossil fuels, and China is one of our main competitors, then we're going to be at a significant deficit in terms of our ability to produce on par with them. And India kind of on the same level there as they've come on and started producing more and more stuff. So you kind of had this tit for tat, we're not going to do it if you don't, and we don't think we should do it because you've already been doing it. And I just don't think it wound up being very effective because those countries, especially the U.S. and China, were the two main producers of CO2 and still are the two main producers of CO2. And then now I want you to add in, we are currently in the middle of another CO2 agreement called the Paris Climate Accord. And so the Paris Climate Accord was signed back in the bunch of European countries, developed nations, and the U.S. hopped on that train, I think, in the Obama years. I can't remember the exact dates. It's not in this book. And then the Trump years, we got off the Paris Climate Accord, and then now I think we're back on the Paris Climate Accord. And so that's a similar thing, like we're going to reduce so much CO2 production per country. And the controversy and the political back and forth there is primarily due to, do we have the means of production without using CO2? How are we going to produce the energy we need to keep our economy going and keep our economy stable and make sure that we have enough, electricity and the things that we need to use every day without increasing the price dramatically? And so that's the issue now, and that's why you kind of see this back and forth political debate about where are we going to get our energy from going forward if we have to dramatically reduce the CO2 production. So keep that in mind. I'm sure you'll hear more about that. I encourage you to be objective, and as you hear these discussions and debates, that you think about both sides and think about, what's the best solution going forward. Next, ocean warming. Let's turn over to page 538. So, oceans are getting warmer, and probably there's a couple big problems associated with ocean warming. We talked about as the temperature of a liquid and a gas increase, what does that cause, Jason?
Evaporation.
Well, it does cause evaporation, but what else? Expansion. So there's a thing called thermal expansion. Excuse me. So we talked about sea level rising being due to sea ice melting, like in the polar ice caps in Greenland. But also you can have sea level rising because of thermal expansion. And the only study I could find suggested that the thermal expansion accounted for maybe up to a third of that sea level rise, which seemed like a lot to me, but I'm not in that kind of science field, so I'll go along with that. So temperature increases, water expands, you got more water coming in from ice melting, and so we see this increase in sea level. So number 22, excuse me here. Ocean warming is caused primarily by the increase in greenhouse gases in the atmosphere. So we see this increase in temperature on Earth. We do most of our measurements on land, but you would expect the temperature in the waters to also increase as well. Okay? Primarily, like we said, we influence CO2 and methane production. Number 23, ocean warming can affect marine species in a variety of ways, including habitat loss. We talked about as the oceans get warmer, like if you're in an intertidal pool and you have to maintain a specific temperature, then that may dramatically affect your habitat and where you can live, because you may not be able to live there anymore. Like our friends what was in the video last week on the 1 degree? The crabs. Remember the crabs? They turn up the dial a few degrees in temperature, and what happened to them? Yeah, their heart stopped. So they started dying. So, and you bio people out there, hold on, I think Luke's the only bio person. Remember, like when we talk about enzymes, when you go, you increase the temperature of enzymes, eventually there's a certain degree mark where like those enzymes start to fall apart and denature, and they don't work any longer. So that can have a dramatic effect if you have to live in a narrow temperature range. The next part of that, including loss of habitat and metabolic and reproductive changes. So metabolic is a term referencing what, DeQuinte? Miss Gigglesworth?
Who?
You giggled.
Metabolism. Breakdown of sugar.
Yeah, so we primarily think of metabolism and breakdown of like sugar and food, but it says metabolic changes. So when you think of metabolism, that's talking about like all the chemical reactions that are taking place in your body. So like I said, anytime you have a temperature increase or even a decrease, we're not really focused on decrease right here, but anytime you have a temperature increase, once you get to a certain point, those enzymes start to just denature and fall apart, and the bonding and the shape falls apart, then they're no longer able to function, and so they lose their ability to work properly. And then also reproductive changes. So we've talked quite a bit about reproduction, Colby. You know, what limits reproduction? Lack of food. Okay, so we talked about food as a big driving force behind your ability to reproduce and make sure you have the stuff you need. And also, when you increase temperature, you're increasing like the stress on organisms. So stress is another one of those driving factors that can affect your ability to reproduce. If you're those crabs and you're playing Nelly out there, it's getting hot in here, and your heart's fixing to stop. So I mean, your reproduction is probably not number one on your list of things to do. Yeah.
Wasn't like a situation like back in the day, like a lot of truck drivers couldn't have kids because of the engine under the seat.
I've never heard that, but that would make sense.
They would get too hot.
So our friend DeQuinte said that truck drivers back in the day were having trouble having babies because the engine underneath their truck. You talking about like the single cab trucks where it was just straight on, the engine, like you had to flip it up. It was right underneath your seat and it was getting hot. Yeah, because your testicles have to stay at about 93 degrees. And if they get too hot, then the sperm production's off. And so that makes sense. Yeah, a temperature increase could do that. I had not thought about that, DeQuinte. Good job.
You know the exact degree that
I'm a biology teacher.
I know, I was thinking,
I figured that's probably right.
those chickens were going crazy.
I know, those chickens are going crazy. All right, so keep that in mind. That's why a lot of people, they say, when you're trying to have babies that sometimes the doctors will tell you to wear boxers because the higher your body, the higher your temperature there, the lower the sperm productivity. Anyway, number 24, ocean warming is causing coral bleaching. So coral bleaching, it's not actual bleaching. We're not pouring bleach in there or chlorine. It is due to the fact they look like they've been bleached out. They're whiter so coral bleaching is when the temperature of the water increases. It's roughly about 86 degrees. Is it okay if I know that temperature, Luke? That once it increases by about up to 86 degrees Fahrenheit, that most of the coral, about 90%, are living in like symbiotic relationships with algae. So they're like almost like farming algae. And so once they get up to that temperature, it's like, bless you, it's like the winter, the summertime starts to warm up, you start shedding clothes. And so it warms up in the coral reefs. There's like, I'm getting rid of this algae, it's just too hot for me. And so if that happens over the course of a few seasons, so it gets warm in the summer, it cools down a little bit, gets warm in the summer. If they expel that algae, then it puts so much stress and strain on them that eventually they will die. And so you can go to places like we went in Northern Australia on the Great Barrier Reef, and you see evidence of significant bleaching because of this increased temperature in the water. Occurs when the loss of algae within corals causes the corals to bleach white. Some corals recover and some die. Like I said, if it's short term, they can recover. If it happens consistently over a period of a few years, then most of the time they will not. And once you lose those coral, you're probably not going to get them back. So let's skip over to number 29. No, hold on, 25, right? So we're going to move on to this section on ocean acidification. And if you'll turn over to page, we're already on 538, so we're good. So 530, excuse me. So ocean acidification. Acidification means to
Increase the acid.
increase the acidity, which does what to the pH?
Drops it.
Drops it from the top, like I can't say that. Okay. So, ocean acidification is I swear my kid said something about that the other day. Oh my gosh. They
Which
said
one?
from the top, make it drop, and I was like, and they didn't say anything else, but I was like, whose TikTok have you been listening to?
Was it Sipsy or Kava?
Shh, I can't repeat those names on the internet. All right,
You
So-
had
They
them.
have their little episodes on your channel.
I don't know who those kids are. Number 25, ocean acidification is the decrease in pH of the oceans. Boom, who knew? So, primarily due to the increase in CO2. Now, let me get out a drink here.
What?
So, anytime you guys drink carbonated drinks, number one on the list of ingredients back here, carbon dioxide is dissolved in these drinks. And that carbon dioxide then turns to
Yeah, bubbles.
bubbles, also dissolves and turns to what acid?
Carbonic acid.
Carbonic acid.
Delicious. Yes, carbonic acid. So, that carbon dioxide in the air, as the CO2 levels decrease, more of that gets dissolved and mixed in the ocean water, and then that level of carbon dioxide increases, and it breaks down and forms carbonic acid in the water, just like it does in your soft drink. And the more you have, the more it's going to decrease the level, the pH level. The more acidity in the water causes some problems, because things we think of that make shells out of calcium carbonate, like most of your mollusk, coral, on coral reefs, that coral is made out of calcium carbonate, and a lot of little microscopic like diatoms and stuff that make up the plankton in the ocean also have a calcium carbonate shell. And so calcium carbonate is the same thing we think of in lime. It's the same thing that's in Tums, and it's very what? Basic. And so if you make this more acidic, what's it going to do to that basic substance? It's going to dissolve it. So this is the same kind of function where caves form. Most caves are made of limestone. And so limestone is made of calcium carbonate, which used to be like part of the ocean a long time ago. And when it rains, as it rains, some CO2 gets dissolved in the rainwater. And that's why we said rain is naturally has a certain acidity, like above 5.5, but usually like high fives or low sixes. And so as it dissolves and runs through that limestone, it eats away at the limestone. So think about in the ocean, if you decrease the pH, the calcium carbonate in shells and reefs and whatnot are going to not harden as much. They're going to be broken down more readily, and it's going to have a negative impact on those organisms. And it says can be expressed in chemical equations. We're not going to worry about the chemical equation now, but you do need to know the acid that's formed is carbonic acid, okay? So that is the acid that's formed as that carbon dioxide gets dissolved in the water. Number 26, as more CO2 is released in the atmosphere, the oceans, which absorb a large part of that CO2, become more acidic. So like I said, the more CO2 in the atmosphere, the more it's going to get dissolved in the ocean water, and the more acidic it's going to become and cause the issues that we just talked about. Number 27. Anthropogenic activities that contribute to ocean acidification are those that lead to increased CO2 concentrations. And that's a lot of stuff there to basically say that humans are burning fossil fuels, and that's the primary cause of increase in CO2 in the atmosphere. Burning fossil fuels, vehicle emissions, which is still fossil fuels. And then the other part of CO2 rise is due to there's less CO2 being taken out of the atmosphere by trees. And so that plays into the lab that we just did. You know, we talked about like if we take just our normal friend, the pine tree, how much CO2 is it taking out of the atmosphere? How many trees do we need to? And I think the last part of the lab we're going to look at today is how many trees would you need to plant in order to offset the CO2 that you produce just by driving back and forth to school every day? So that's something we're going to look and think about, because you know, we have to consider our actions. Are we able to mitigate the things that we do, the consequences of those actions? And then the last one, number 28 here, ocean acidification damages coral. So remember, coral is made out of calcium carbonate, and because that acidification makes it difficult for them to form shells. If you didn't know this, coral is basically, Jason, it's like a jellyfish that's upside down and it's like attached to a rock. And so over time, it secretes what we would say the coral reef. And so it's secreting so much calcium carbonate every year. It lays down a layer and layer and layer. It takes a really long time, thousands of years, for like a coral reef to build up. And so if you're having difficulty because of the acidity forming that calcium carbonate shell, then it's just going to make your life more difficult to live. All right. Any questions on ocean warming or ocean acidification? Happy Friday.